Thank you for your introduction. My name is Nami Ogawa from the University of Tokyo, Japan. Today, I'd like to talk about how the representation of a self-avatar influences the way we perceive the scale of our virtual object. In virtual environments, users interact with virtual objects through their virtual representation of a self-body called avatars. Avatars in current virtual reality systems are highly customized to individual users. For instance, they have various levels of realism, from realistic to abstract. And their sizes are often generic, regardless of the user's actual body size. This background conveys the question that how does avatar appearance influence the way users perceive the virtual world? This is our main interest in the study. More precisely, we studied the effect on object size perception. In the next few slides, I'll explain why we focus on object size perception, which is apparently unrelated to avatar appearances. In terms of realism, it is well known that it affects the self-body perception, such as the sense of body ownership. Previous studies have shown that the closer the avatar appearance is to our own bodies, the stronger the sense of body ownership. But this is not surprising that much because it means how we perceive the self-body depends on the appearance of the virtual body. So we were interested in whether the avatar realism could affect not only the self-body perception, but also the perception of objects which users interact with through the avatars. That's why we focused on body-based scaling, which is the theory that we use our bodies as a ruler to perceive the scale of the world. Prior studies have shown that when the size of the avatar is enlarged, object size is perceived to be smaller, and for smaller avatar bodies, object is perceived as larger. It looks like just a visual trick of the contrast of scale, but what is interesting is that the scaling effect was found to be greater when participants experience the sense of agency than not, even when the retinal input is the same. However, the effect has only been studied in human avatars or realistic artificial bodies. So it's still unknown that if this holds true when we embody non-human or object avatars. To summarize previous studies, avatar realism affects body ownership, and hand size affects object size perception, but only in the case of human avatars. Therefore, this study examines and explored the relationship between avatar realism and perceived object sizes by taking the body ownership into consideration as a key concept to link them. Our hypothesis is that the more realistic the avatar, the stronger the sense of body ownership, and it fosters the effect of body-based scaling. Then the size of the objects are perceived based on the size of the avatars. In contrast, the less realistic the virtual hands, the weaker the sense of body ownership, and it attenuates the effect of body-based scaling. Then the size of the objects are perceived independently of the size of the avatar. So now I'm going to give an overview of the experiment. The independent variables were avatar realism and hand size. The level of the realism was any of high, medium, or low, and hand size was either the same size as the user's actual body size or enlarged by a factor of 1.25. And we measured two variables. The main dependent variables was the perceived size of the cube. It was measured by a size estimation task, which I'm going to explain in the next slide. In addition, after the main experiment, we measured the strength of the sense of body ownership by a questionnaire for each level of realism. 24 individuals participated, and each participant conducted 108 trials in total. So here shows the trial flow. Each trial consisted of a cube carrying task and the following size estimation task. In the cube carrying task, participants carry the cube with a virtual hand of various appearances to a target position and remember the size of the cube. In the following size estimation task, they reported the perceived size of the carried cube by adjusting the size of another cube so that its size corresponded to the carried cube by pushing buttons of a controller. The hypotheses of the experiments were as follows. First, the more realistic the virtual hand, the stronger the sense of body ownership, as previously shown in the literature. Next, with enlarged realistic virtual hands, object sizes are perceived to be smaller compared with veridical hands. This has also been shown in the prior studies only in the case of human avatar, so we expected that it happened at least in the high realism condition. The most important hypothesis, A3, is that the less realistic the virtual hands, the less the impact of changes in hand size on the object size perception. So H1 and H2 is a verification of the previous studies, and H3 is our main hypothesis. Now let me show the results of the experiments corresponding to each hypothesis. First, here's the result of the questionnaire. The figures show the questionnaire ratings of body ownership for each avatar realism. As expected, the avatar with lowest realism provided the weakest body ownership, even though there was no significant difference between high and medium realism avatars. This partially supports hypothesis 1. Next, this slide shows the results of the size estimation task. First, we calculated how large or small the cube was perceived to the participants by dividing the answered cube size by the actual cube size for each avatar appearance. The vertical axis represents this value. Before checking hypothesis 2, I'd like to briefly explain the overall results. Overall, the cube sizes were overestimated in all the conditions, including veridical condition. Another interesting point is that even when the hand size is veridical, the perceived size of the cube was different between its low realism and the others. These are interesting observations, but I don't have time to go through it, so please check our paper for details. Now let me go back to hypothesis 2. The results in the high realism conditions showed when the realistic hand is enlarged, the size of the cube is perceived to be almost 3% smaller compared with the veridical hand, confirming hypothesis 2. What is interesting here is that it only happens for high realism avatar, not for the others. So in order to further investigate how the effect of body-based scaling is modulated by avatar realism, we calculated the effect of hand enlargement on cube size estimation for each realism. It is the normalized ratio of the value in the enlarged condition to the value in the veridical condition. By using this index, our main concern in this study, hypothesis 3, can be tested. The bar graph on the left shows the index for each avatar realism, indicating the extent to which the effect of body-based scaling was observed. As you can see, the amount of the effects was significantly different between high and low realism avatars. It shows that the less realistic the virtual hands, the less impact of body-based scaling, and confirming hypothesis 3. To summarize, our findings show that avatar realism influences not only body ownership, but also object size perception through body-based scaling, especially when compared between highly realistic human hand and object avatars. It indicates that there is a trade-off. That is, the more realistic the avatar, the stronger the sense of body ownership, and it's a good thing. However, at the same time, the more realistic the avatars, the more easily the users are influenced by difference in avatar size to their own size in terms of object size perception. This trade-off provides an insight for a design guideline of avatar appearances. We recommend that if designers want to achieve a strong sense of body ownership while keeping consistent scale perception among users, then it's better for the virtual hand to be realistic and have a personalized size for users, especially in scale-sensitive VR scenarios. As for future studies, it is necessary to investigate whether the effect can also be verified with further objects which users cannot directly interact with, because the scale of the external environment rather than a particular size of the particular object is more important for some applications. In addition, it's also interesting to see if our action is also influenced when we visually perceive the scale of the object as smaller. These 2 points for the object and motor control are verified in the previous studies of body-based scaling, so we expect that they are likely to be influenced by avatar realism as well. Lastly, it will be also important to know how much the body-based scaling is strong when compared to other size cues, such as familiar object size and the height of the view. This study focused on the unexplored relationship between avatar realism and body-based scaling, that is the effect of hand size on object size perception, and show that evidence that avatar appearance affect the way we perceive the size of the virtual objects. That concludes my presentation. Thank you for your kind attention.
We have time for a question.
Hi, thanks for the talk. There's another dimension of hand appearance, which is likeness. So a realistic hand, like you have on the left here, may look like a human hand, but it doesn't look like my hand. And for instance, the lady here, to me that looks like a male hand. I was wondering if you explored likeness as well.
We only investigated their sense of body ownership, as previous studies shown that avatar realism affects likeness or like that. So we only focus on the size estimation and body ownership.
Okay. The body ownership results indicated that the high and the medium had a similar level of body ownership.
Yep.
It may have something to do with the fact that the realistic hand doesn't look like my hand, so that may cause discomfort. Yep. So it'd be interesting to follow up.
Yeah, it's interesting further studies. Thank you.
Okay, we have to move on, but
just a short question.
We'll have the other speaker come up and set up. The next speaker.
Hi, nice talk. I'm Songcha from HitLab New Zealand. Actually, we had a similar experiment last year, and we published it to SUI. But we found that when we have a purely personalized hand, then its accuracy was very higher. I'm just wondering, how did you match the hand size per person?
You are asking how we measured hand size for individual? Yeah. Actually, the motion controller could automatically personalize display the personalized hand for each user. Did I answer your question? Okay, thanks.